Good morning, good afternoon. Thank you for joining us today in this Blue Cafe. It's great to see so many of you online. My name is Jingzi and I'm a host. Today we have Henrik and Rasmus with us who will share their experience in the development and usage of the Mike.io Python library. Before we start, I would like to say a few words about Blue Cafes. This is an informal virtual space where we share our latest research and innovation work at DHI. We would like to use this space to not only inspire you, the things that we do, but also get inspired and learn from all of you. So if you have questions or comments during the presentation, please feel free to enter them in the Q&A section at the bottom of this Zoom webinar. And we'll try our best to answer all of them towards the end of the session. As usual, the Blue Cafe is recorded, and the recording will be made available to you by email after the webinar. So this is the kind of the distribution today. I think it's going to be quite interesting. We have a number of people with some experience and some people with extensive experience. So it will be hopefully a good exchange of information. So without further ado, I will hand over the mic to Henrik, who would start the presentation. Henrik.
Thank you. So first, we have some acknowledgements of people who have already contributed to this open source Python library. So these are the names of the current contributors, and I guess this list will be longer in the future. This is the outline of today's presentations. First, some motivations of why we did this. What is it all about? How does it work? And then we'll show a lot of examples in Jupyter notebooks. And then we will end with some experience and potentials about this project. So why? There is the aim of this library is to be able to exchange information between Mike model simulation files and Python. And why Python? Because Python is free to use. That's quite important. And on top of that, it has a lot of libraries which is relevant for our domain, such as NumPy, which gives us vectorized computations, similar to how MATLAB works. Pandas, which is the standard tool for tabular data and time series. SciPy, which gives you multidimensional interpolation, statistics, optimizations, search algorithms, and many other things. The Shapely library, which gives you geometry operations, things that you would normally do in a GIS system. The X-Array library, which handles multidimensional data very good. It's like Pandas, but for multidimensional data, and it can read netcdf files. Scikit-learn, which is the industry standard library for machine learning. Python can be used both interactively, as in a Jupyter notebook. We can make a web application, but you can also deploy it as an operational service in a script. So I think that Python is a very flexible tool and something that we would like to use together with our Mike data. The design philosophy behind this library, Mike.io, is that it should be easy to use. For instance, you should be able to read the file with a few lines of code. It should be easy to install, and it's installed using the normal Python installation mechanism pip install Mike.io, and then you have everything that you need. It should be easy to get started, and I like to learn from examples. So that's why we have made a number of Jupyter notebooks with examples of reading and writing. So you should be able to copy paste those and modify it to your needs. It's open source, so contributions are welcome, and we will get back to this later. It should be easy to collaborate, and that's why we have it on GitHub, and we'll also get back to that. It should be reproducible. So if you deploy an operational service, you want to copy that to another server, you want to be able to install exactly the same version of the library. And so that's why we have versioned releases, so you can install a historical version and get exactly the same behavior. It should be easy access to new features. So you can choose to install the latest released version, but you can also install the latest version directly from GitHub. Now I will hand over to Rasmus, who will talk about open source at DHI.
Yeah, we just have a couple of slides before showing you some examples of how to work with this package. But we started working with open source at DHI. This is not the first project, but we really think it contributes to more transparency. You're able to see the code, how we handle these mic files and the data. And it's way faster for prototyping. When using Python, you can use all these libraries, and you can change the code, modify it as you like. If you get your own copy, you can also contribute to the code. So if you need a new feature, there's not a lot of developer bottlenecks. You can do it yourself and modify the code. And also share the code in general. So that means you have reusable components, and it's developed in this collaborative effort. So we can rely on each other's contributions. I think that's very helpful, and it will also provide better quality code. There are more eyes on the code, and we have code reviews and that kind of stuff. So I really think it's a really nice workflow. And if you change the slide here, now you'll see our GitHub profile page. There's a link at the top of this slide. It's github.com/DHI. You'll see some of the open source repos that we have, and you will see Mike.io at the top. That's also, it is truly an open source project, because we have a bunch of contributors from all over the world, also external contributors, clients who wrote code and merged it into this package, so they can target it to whatever their needs are, and then everybody can reuse that functionality. Yeah, that's it.
Thank you, Rasmus. So let's move on to how it works. I will show some examples of how to use this, how to read files, how to modify files, how to read Mic 1D files, how to convert files from other formats such as comma-separated file, and lastly to aggregate over spatial axis. So it's almost time for notebooks. So let's see. First, we import some standard libraries: NumPy, Pandas, Matplotlib, and we will start with reading DFS0 files. So import DFS0 class. And the first thing we do, we construct a DFS object, and it reads the header of the file. So we see this equidistant file, and it has one item with water level, and we can read that data with the read method. And the read method returns a data set. And the data set, it has some properties like the list of items. It has the time axis, and it has the actual data. But for a DFS0 file, which is a simple time series, I think it's best to use the pandas library. So we can choose to convert this data set into a data frame. Now it's a standard pandas data frame. We can import data from a text file, and that's it's also done with pandas. So we can read a CSV file, which I have here, and it's tab separated. We have the time in the first column. So that's a pandas data frame from a text file. And to convert that to a DFS0 file, we can do it like this. Now I created a DFS0 file with the same content. We can read DFS2 files. And now I've read the header, so I see the spacing and the items. I use the same mechanism as for the DFS0 file, so I read the dataset. And the dataset, we see that it has one time dimension. In this case, it's only one time step, and the y and the x dimensions. So we can pull out the first item of this data set, either by indexing with the positional index, or we could use a name, which I think is more descriptive. So elevation is this one. See, it is a three-dimensional array. So that's the first time step of this one. So this is a map of the bathymetry in the Öresund region. Maybe we should have a color bar. Let's move on to mesh files. So a mesh file is an unstructured grid file. It has a number of elements, a number of nodes, and a prediction. And you can choose to plot this file. So you see, this is a mesh of the North Sea. We can pull out the X and Y and Z coordinates. So Z coordinates is the third dimension of this array. So like that, then we can see that the deepest part of the North Sea is 3,800 meters or so. And for some reason, I want to modify this, so I can restrict it to only 3,000 meters. So now I have this new variable, set new, and I want to update my mesh with this newly constructed variable. So I set the set value to set new, and then I can write it back to disk, new mesh. So pretty straightforward to modify the mesh. I guess you can think of a lot of different things that you would like to do, like smooth the mesh, but that's out of scope for this library. We focus on reading and writing mostly. But we want to interact with all the other Python packages. So for example, working with things, geometric objects like this is best handled with Shapely. So I can construct a Shapely multi-polygon with this to Shapely. So now you see this is a multi-polygon, a lot of small triangles. And I can do some interesting things. I can construct a single polygon by buffering with 0 meters. So now I have a one polygon with an island inside. And I can get the boundary as the polyline. So this is the exterior. And what else can we do? We can calculate the distance from all the points to the exterior. We can do this with an comprehension for polygon in multi-polygon. That's a long list. I think I can convert this to an NumPy array. And then we can visualize it with the so the plot method which I showed before, by default it shows the bathymetry, but I can pass in a different array here, so I can pass in the distance, and now suddenly I visualize the distance from every polygon to the outside. And if I want to save this as a DFSU file, I can construct a DFSU file. And use the mesh as a kind of template. Of course, I forgot it doesn't have a time dimension, so I need to create a time dimension. Now I have a distance DFSU file created from this. Let's do some more things with DFSU files. This one is a three-dimensional sigma set file, so it's a bit more complicated. It has a number of elements and nodes and sigma layers and set layers, and has three different items. A three-dimensional DFSU file always have a set coordinate as the first dimension. And we can, for instance, extract the top elements from this file. That's the an array of the indexes of the top elements. We can take a look at the. Oh, yeah, sorry, we have to read the data. Read the data in the top elements. So now I have a data set with 3,700 elements. That's a subset. You see the full file has 17,000. And we can plot this. That's the first time step, or the second time step. What else can we do? We can find a position to some location, find nearest element, whatever X and Y coordinates that you have. And we can choose to read just that position. And then we have a very small data set. Let's move on to Mike 1D. We can read res1d files. First, we construct a query. res1d query. So I am interested in water levels. And when I read res1d, it always returns data frames. And it retains, in this case, it returns a lot of columns. So maybe I want to filter a bit more careful. So then we want to specify a specific reach. Like this one, for instance. And now I only return 2 columns. The last thing that I will show is spatial aggregation. So DFS2 to DFS1, or you can also do DFS, any type of DFS to DFS0. So if I have a DFS2 file, I can construct the DFS1 file. So an average over one axis in one line. I can choose which axis. So by default, it's the y-axis. Default one y, yes. I can choose to do it the other way. Or, of course, I don't want to have the average. I want to have some other function like max. Then I supply a different aggregator function. So that's done in one line of code. Now we'll go back to the PowerPoint slides. Sorry. So Mike.io has been constructed with a philosophy called test-driven development. The first step of test-driven development is the red step. That's you write a failing test, a failing unit test, and then you go to the green step and you implement only as much code as necessary to pass this test. And then you can refactor the code, so you can modify the code to improve the reuse, readability, or performance, and then you repeat this loop over and over until you're satisfied. So in this process, test-driven development, you end up with a lot of tests that describes how you want this library to work. So we have managed to create a test suite of over 200 tests. So when we refactor things and change things, we can run all the tests, and it's automatically run in GitHub using GitHub Actions. So when you have people checking in code, external collaborators or anyone, we can see that the test passed before we merge it into the main branch. So here below you see an example of a test converting a data set to a data frame. And so first of all, the tests are therefore to test that the functionality works as expected, but it also serves as an additional collection of examples in addition to the examples that you find in the Jupyter notebooks. Mike.io it's still a young project, but it's mature enough that we think of it as a technology readiness level of 7. So a system prototype demonstrated in the operational environment, and we use it for operational services, but mostly it's used in interactive work, but there it works fine. Doesn't mean that it's finished yet, so we will still add new features and improve on the library. Are there any pitfalls to this library? Yeah, it is a young package. and the interface might change. So we're renaming things and changing things to make it even easier to work with. So if you download it today or in a month, there might be some changes. There is no official support from the MIC organization, so you will rely on voluntary support by writing issues on GitHub. And a third pitfall is that it's not yet available for Linux, so it's a Windows-only package. But what are the potentials? Yes, as I mentioned before, you can use the entire Python ecosystem of libraries. It is, I think that you have been convinced that it's easier to get started with MIC data processing. There is no commercial license necessary. You don't need a MIC license or MATLAB license or any other type of license. You can just install it and start working. It is useful for interactive work, exploring the data, but you can also use it for operational services or to make reports. So how can you contribute? Rasmus, do you have some
Yes,
ideas?
you can just change the slide here.
Change to the next slide.
Yes, please. So yeah, if you would like to contribute, that's you can basically go to the MIC.io repository landing page here. You can contribute just by opening a new issue. If you find a bug or you would like to request a new feature, you can open a new issue here, and there'll be people looking at this and discuss if it's already there or what we need to do about it. And if so, you don't need to learn how to code, how to report an issue or request a feature. You can just do it here through this the GitHub web page. But if you would like to contribute, you can then fork the repository and you can add modify the code, and then you can open a pull request to get your changes back into the master branch of the package, and then it will be released if it's approved, all these changes. So yeah, I really encourage you to go there if you need anything, or if you have a feature request, maybe it's already an open issue that people are working on. So you can check that out. Yeah.
All right, I think that's the end of the presentation. Thank you very much for all that, Rasmus and Henrik. We will start off with a tadpole questions before we go to Q&A. So while we are at the poll, if you have any questions, comments, please feel free to enter them in this Q&A section. Okay, so let's maybe jump to the Q&A.
Okay, I will read some questions here from the questions and answers. One question is, how can you convert the Wind input UNV components, which is in an SCF file, to a DFS2 format? You can do that by looking at the GitHub page and find a suitable notebook, because I have an example which does exactly this. So you should be able to copy paste that code without any problem. Is it possible to start mic runs from MIC.io? No. That's not part of MIC.io yet. We're considering to add functionality that you can modify, read and write the setup files, and then of course you can start the engine from Python. But as such, we have not considered this as part of MikeIO yet, but maybe you can write an issue on GitHub and explain why you think this is useful, and or add the functionality yourself.
I would like to add that,
yeah,
like that yeah, MikeIO, as the name indicates, is mainly input and output of the Mike data and the files. But of course, you can, if for instance, the Mike 1D engine, and we also have examples on GitHub on how to run that from code. So you could prepare all the simulation data with MikeIO, and then all the input files, for instance, and then it is possible to use the Mike 1D API and run that from Python to run your simulations. I've done that on several occasions, and that works really well. I'm not sure about other Mike engines, but at least Mike 1D, that's what I work with. You can use that. And there's a question about Linux. That's mainly to do with so why it's not working for Linux, because we rely on a Python package right now called Python.net to interface to all the C# DLLs that we use to write and read these files, and that is not yet compatible with Linux. But there might be a way, or what, Henrik, I think?
I think so. Maybe it's not so straightforward, but if there's if this is a pressing issue, then maybe you will get it prioritized. There is a question: do you have any functions to import CFSR, wind, Waywatch 3, or other public hindcast data? Yes and no. I mean, they all come in netcdf files or a GRIB format. So you can download the data and you can convert it to DFS using MikeIO. And I have examples which downloads wind data from an opened up server. So this is certainly possible, but we're not going to make any specific functions in MikeIO to download data from public sources.
There's a question about how to prepare the data sets, and I think we have more notebooks on the repository you can check out if you have problems how to do this. Otherwise, yeah, I think you showed it as well, Henrik, today. But yeah, there are examples on GitHub.
It's a question about if there's any documentation for the MikeIO library. There is a documentation page which you find at the top of the GitHub page. But as I said, I think it's best to learn from the examples. And the documentation is made in doc strings in the code, so you get this feedback when you're typing inside the code editor or in the Jupyter notebook. So you get helps with the parameters and with functions and what methods are available. Rasmus, can you explain what about collection systems and water distributions? Do we have anything for that? The REST1D, it's is that for?
Is that a specific file format or what?
I mean, there's a question about collection system and water distributions. Do we have anything that handles that?
No, not yet. But yes. Yeah, I don't know anything about these collection systems. I do, but I mainly use Mike 1D, and yes, I don't know which file types are required here. If that is what is that the question? I think.
Yeah. I mean, this is made in a way that we solve our own problems. So I'm mostly working with the marine simulations. So I use DFS0 files, DFS2 files, and DFS2 file and mesh files, and I have created these functions to help myself. So if there is somebody that badly needs functions for collection systems, then it's just a matter of collaborating and participating in this library. That's this is not a top-down project. It's a bottom-up. A question: does Mike.io has all the functionalities of the DFS MATLAB? I'm not sure because I haven't used MATLAB in a long time, so I guess it doesn't have all the functionalities of the DFS MATLAB, but it might have functions which are not part of the MATLAB. So both good and bad.
Someone mentioned here that regarding water distribution, that is the engine is EPANET, and it's got its own Python library you can use. There's a question about creating DFSU or DFS2 files from Pandas data frame. Isn't that pretty much what you showed, Henrik?
I mean, a DFSU file is kind of complicated. If you want to create the entire structure with the connections between all the elements, but if you have that and you have the data in a data frame, then it's certainly possible.
Someone asking about machine learning tools, if you can take a DFS2 file and predict some parameters, and of course that is possible, but not with Mike.io. That's only data handling of the files. So you can use it to load the data, and then you need to use some, for instance, scikit-learner or some of these other tools to process the data and train your models or whatever you would like to do machine learning wise. But this package is only for reading the data, writing the data.
But I mean, not only. It is an important component of a machine learning workflow if you want to use the Mike files. So certainly possible, but that's the machine learning part is out of scope for Mike.io. But we certainly encourage you to explore that. And so, question: can you transfer the exterior polyline from Shapely to a shapefile? I'm pretty sure you can do that. But that's, as I said, that's not part of Mike.io. That's Shapely or Fiona or other GIS package. So we just interact nicely with the existing libraries. Are you planning to develop other packages beyond I/O, for instance, for automatic modeling? Chengxi, do you have an answer to this interesting question?
I think we'll try to develop that, but I think that will be a separate package apart from Mike.io. So maybe we can take a few more questions before we end the session. So if you have more questions, please just enter them in the Q&A part.
A few questions about GIS tools, but I don't know anything about this.
There's a question: is Mike.io the best bridge to import and process your data using GIS tools? I don't know if it is the best bridge, but if you like Python, then that's the best we got. But maybe there are certainly other ways to do it.
With that, I think that's the end of the session today. Thank you very much for your time, and I wish you a good day ahead. Bye.